and we're asked to graph y equals 4f of negative 0.5x and see what it would look like. Stay in the domain and range of each. So when we look at this, what do you think this 4 is going to do? It's going to affect the y. It's going to multiply the y by what? By 4. So again, anything that happens outside of your function is going to be intuitive in what happens. It's going to multiply your y by 4. The next numbers we run into is our negative 0.5. That's going to multiply your x by negative 2. So now if we took some key points, the most important point will be this one because that's where our function starts. So for sure we're going to look at what's going to happen at negative 2 comma 0. If we wanted to look at some other points, looks like we've got negative 2 comma 2 there, or sorry, 2 comma 2 as another point. Are there any other points that look nice on the graph? Negative 1, 1. Negative 1, 1, and 8 comma 3. So let's just do those 3 points to see where they end up. Now, as far as showing our work, you can do this all in one arrow. We can do multiply y by 4 and x by negative 2 all at the same time, because one's going to affect the x coordinate, the other one's going to affect the y coordinate. So if I multiply my x by negative 2, I'm going to get 4. My y by 4, I'm going to get 0. If I multiply the next one, my x by negative 2, I'm going to get negative 4. My y by 4, I'm going to get 8. And finally, if I multiply my x by negative 2, I'm going to get 2, and y by 4, 4. And I'm going to put an asterisk beside that first one. I'm going to just call it a starting point, because it was the starting point of my square root graph that I see there. And now it is going to be the starting point after I've done all of my reflections and stretches and compressions. So if we label our points, I'm going to have 4, 0, which is right there. Negative 4, comma 8, which is off my graph. And 2, comma 4, which I could still put here. If I did estimate where negative 4, 8 would be, probably way up there. And which was my starting point? 4, comma 0. That's going to be my new graph. If we think about what's all happened here, the 4 is going to stretch it vertically by 4. Then it gets stretched horizontally by 2. And with the negative inside, it's getting flipped over the y. So it should make sense that my graph, the green one, is going in the other direction than my original one was. And it definitely looks like it's been stretched. More stretched vertically than it was stretched horizontally. By the way, what do you think the red graph's equation was originally? Root of x plus 2. Good. So that's my original graph. Now, what is the equation of my green graph?
Y equals 4f bracket minus 0.5x plus 2.
Y is equal to 4 square root of negative 0.5x plus 2. Whew. Now, if you can go to that directly, that's great. If you're looking at me like, how did you go to that directly? Let's take a step back. Let's think about we know that the original graph f of x is equal to the square root of x plus 2. Move 2 to the left. And we want to find the equation of the green one, which according to function notation looks like this. So what we need to do is take the function notation and write it in explicit notation. The way that we do that is everything outside stays outside. So the 4 starts there, no problem. We now have to rewrite this. And the way that we rewrite that is we say, wherever I had an x, that now has to get replaced with negative 0.5x, because that's what function notation does. Whatever you put into the function replaces the x. So now I rewrite my function. I'll keep it green. But instead of writing the x, I have to write negative 0.5x. And then I still had the plus 2 after it. So that's how we can take something from function notation and change it back. Okay. Did I give you questions for this one already? No, not yet. 7, 9, and 10. Yeah. Domain and range. Our original one, our domain x was bigger than or equal to negative 2. And our range y is bigger than or equal to 0. I'm just going to write that in set notation. And on our green one, I'll write our domain and range in the interval notation. Can you see that it's everything less than positive 4? So we would start at negative infinity and go up to positive 4. And our range is everything bigger than 0. 0 would be included. Again, if you're asked to write domain and range, you could choose to write in set notation as I did with the red one, or you can choose to write in interval notation as I did with the green one. I'm going to show you one other thing just to keep things straightforward, because then eventually we're going to combine all of our functions. So we've got the explicit equation here of the green graph after we changed it from function notation to the explicit equation. When I look at that explicit equation, I see the 4. Does that make sense as a vertical stretch by 4? I see the negative 1/2, which makes sense as a reflection over the y and stretching our x by 2. But when I see the 2, I think you should move 2 to the left. But when I look at my green graph, it doesn't look like it's been moved 2 to the left. What does it look like? It looks like it's been moved 4 to the right. So how do we reconcile that? If it looks like it's been moved 4 to the right, but our equation right now is telling us it's been moved 2 to the left. Maybe we need to move things before we reflect them, but we tried that before, right? We tried moving up before we reflected, and it ended up being the wrong thing. So in order to make that work for us, what we're going to do is we're going to factor out the negative 0.5. When we factor negative 0.5 out of negative 0.5x, can you see that you would just get x? That's no problem. Harder, though, is factoring a negative 0.5 out of 2. So ask yourself, what would have to be here in order for negative 0.5 times that to give us plus 2? Would it have to be positive or negative? It would have to be negative, so we'll put a minus sign there. 0.5 times what is 2? 4. And when we write it in this factored form, can you see the 4 to the right show up? So that when we combine everything together, there's going to be a special note that we're going to look at whenever there's a horizontal stretch or reflection mixed with a horizontal translation. You're going to always have to write it in factored form in order to see how that's going to work. Another thing that we're going to find out when we put things together is you can always work from left to right. The first thing you can look at is multiplying y by 4. Then multiplying your x values by -1/2. And then finally moving them all 4 to the right. And that would match up perfectly with the graph that we have here.